When we first started out, probably about up until the past 6 years, mainly all we did was just field service work, okay? We would go out into the field, troubleshoot a machine that's broken down, replace ball screws, bearings, spindles, you know, any mechanical components. We would also, you know, do the electrical side of it, and we would do training, production support. Pretty much if it involved a CNC, we would support that. And now what we do is we come in and we've gotten into this rebuild, you know, process because so many companies want to redeploy the assets that they have with their high-end machinery. So we've been really blessed with a lot of business and providing those services now. My two sons work with us, Nathan and Josh. They've worked with me ever since they were, well, probably definitely in high school. Both of those went through the Jackson Career Center taking precision machining. So they're definitely my two right-hand guys without a doubt. So they're starting to teach me now. So it's kind of the roles are starting to reverse. My wife, she's the office manager, service coordinator, bookkeeper slash, you know, whatever needs to be done. So, you know, she's definitely involved in the business. We have some other fellers that are working with us now, some younger kids that we're, you know, bringing up and trying to train. Another guy that's that we hired that's doing an excellent job. That, you know, came in. He owned his own business that didn't have anything to do with the CNC field, but with him owning his own business, he had an excellent work ethic, and he's doing a great job.
A lot of our customers are in Indiana, Michigan. I think we just picked up a good customer in Ohio, which is a good-sized job.
General Motors is a customer, Metaldyne's been a customer, Diversified Machine, Chrysler, we've done a lot of work for Chrysler.
We'll travel overseas, we'll travel throughout the United States, or projects. I would think traveling overseas would involve a project, because I can't imagine a service call. Hey, hop on an airplane. Can you fix our machine? You know, of course that would be local. But we do hop on an airplane in the United States. And
what we have here is we've got a Cincinnati lathe that we received from a customer up in Grand Rapids, and the machine is a little wore out. So what we've done is we've tore the machine down to the machine base. We've cleaned the entire thing. On this particular machine, what we're going to do is do a complete paint job on it. We're going to rebuild the slides, which are here, and also rebuild the turret. The slides have turkite on them, so we're going to replace the turkite with a process that's called Moglice. This machine here is one of 6 that we're rebuilding for General Motors. On this machine, we receive it when it just came out of production, so they're pretty ugly looking. We go through, rebuild all the spindles. We send the spindles out to have those rebuilt. We use a company here in Michigan, Superior Spindle, to do that. All the ball screws, we send those out to be rebuilt. We use Roberts ball screws for that. They do an excellent job. We rebuild the LM guides, the LM trucks on them, put new wipers and seals, and put all new bearings in. Rebuild the B-axis tables, replace air lines, coolant lines. I mean, this is a from ground up rebuild on this machine. This machine will be in like new condition when we're done with it. And then we also are tooling these up to manufacture connecting rods. This machine is a big twin spindle lathe that we're reconditioning for a company down in Fort Wayne, Indiana. This machine, we're not doing a total rebuild on it. Basically, we're doing what we would call a refurbish. We're going through and cleaning the machine, rebuilding the turrets on them. Spindles are good. We don't have to do anything with the spindles, and repairing any guards and covers that may need to be repaired. We also are going to be integrating a high-pressure coolant system to this machine, and maybe some other options that they're looking at. This is a machine that we received from General Motors. This is how we usually receive the machines, and this one is actually in a lot better shape than what a lot of the machines that we receive are in. As you can notice, it's, you know, hoses all over the place, it's dirty, so we tear everything down, you know, clean, repaint, rebuild.
One of the great things about being in this building, other than being close to home and convenient, is the other companies that are in here to support. We each try to support each other if we need help, include each other in projects when there's a project that we can use another company in here. Fixture building, machining.
We really couldn't afford to go in and purchase a building because we need overhead crane and a lot of, you know, 480 power and everything to operate the equipment that we work on, and this was available, and it's a perfect fit. These are 3 machines here that have already gone through the rebuild process, okay? This machine, we've already done a capability study on this machine. It's been ran off. What we have been working with General Motors is we've been doing some process development with them to improve their process. What we're doing here is we're machining connecting rods. Just a small connecting rod. This is a connecting rod that goes into the Chevy Volt or the Chevy Cruze. It's just their small 4-cylinder engine. So on this particular machine, we're just doing some boring of the pin end and the crank end and some back champers and everything. And we can hold tolerances on this machine from center line to these 3 bores within about 3 microns. So it's pretty darn close. Yeah, we can do a little clamp here. We'll show you kind of how the part goes in the machine. This is my son Josh. He's the youngest of the 2 boys. What he's doing is just setting the machine up in manual mode so we can do a manual clamp on this right now. And taking some chips out. That's some of the process development that we got to do with GM is increase some feed rates on this so we can get some good chips to break up. The parts locate, clamp in, and the machine, you know, obviously runs automatically. Does a full cycle. Machine's 6 parts per cycle. Fixture index is around 6 more parts. Unclamp, change out to raw parts.
We get good feedback. We often have customers call us when an engineer's on a job and just tell us how happy they are with both of our sons, actually. And that's kind of neat, not just from a business perspective, but as a parent. It's nice to have someone call and talk good about your children. So as a business, it's a win-win situation.
I really couldn't put a finger on what we really specialize in because, like I said previously, if it has to do with a CNC machine, we can take care of that. I mean, we can work on the electrical, we can work on the NC programming, you know, we can do the ladder logic, we can do the integration, we can do the repair work. I mean, there really isn't any aspect that we can't do. So I guess in total, we specialize in CNC equipment.
We have several employees here, guys on the floor, from prepping the machine to rebuilding, tearing the machine apart to painting. But as far as the office goes, I myself work in the office, and I have a assistant, but she's not really assistant. She's like, she can do many things like IT work, order parts, pay the bills, let me know how much money I can spend in the credit card.
This machine here, that's what we call an Op 7 machine. This machine here is our Op 10 machine. What we're doing with this particular machine is we're machining all of the bolt holes in the connecting rod. Okay. After the connecting rod goes from this machine, it would go in and get a bushing pressed in it on some other operations. They would go in and get laser etched, and they actually fracture the cap on the connecting rod on this and then put bolts in it. Then it would come over to the Op 40 machine, which then will do all the finished bores and everything on this particular part. As you can see here, the part is already bolted together. Part loads in like so, and locators expand, then they retract, and we can go in and do all the finished bores and put the lock slot in that. So what we did to this machine is it started out like the earlier machine that we saw that was in the dirty condition and everything, and tore it down and brought it up to, you know, to 100% in like new condition. We've also fixtured the machine up, what you would call, you know, tooling the machine up. We put the tooling, you know, the drills and mills and all of that into the machine, and we've programmed the machine, done the NC programming. There was some, you know, logic changes that we had to make, some ladder logic changes in order to upgrade to some safety systems and everything. So we've done quite a bit to it, and we do it all ourselves, except for the fixture. We have the fixture built outside. But everything else, all of our logic changes, all of our NC programming, we do ourselves here. Mostly Josh and Nathan do most of the NC programming and logic on the machines. On this particular machine, we're also doing some process development for General Motors. We're drilling the bolt holes in here, and they're having a bit of a problem with their capability on these bolt holes. They're varying about maybe 40 microns, which isn't very much for a bolt hole, but they want it a little bit closer. So Nathan has been doing some tool development on these to put a more rigid tool in here so we can hold position better with the machine. On this particular machine here, we're just getting ready to power it up. This is one of our employees, John. John came to us, probably about 4 months ago, maybe? Like that, 4 months ago, something. And John previously owned his own business, and which has nothing to do with CNC equipment. But him owning his own business gives him excellent work ethic. It's very refreshing to have an employee that has a good work ethic and that's here every day and does a good job. On this machine here, what we've done is some of the components we don't go through and do the rebuild on that ourselves, like a small hydraulic unit, something like that. What we do with that is we send that component out to a company in Jackson, Hydraulic Systems. They go through that unit from head to toe. They replace all the bearings in the pumps, replace all the bearings in the motors, replace all O-rings and seals, and test the unit before it comes back to us. That way we know it's a good unit, it's sound. And they've done an excellent job for us. High pressure coolant systems, we send the pumps out to a place in Grand Rapids, and they rebuild those systems for us. Coolant tanks, Hydraulic Systems again, we sent the coolant tanks out to them. They welded new bottoms in them. The coolant tanks are notorious for having pitting and leaking in the bottom, so they welded all new bottoms in them, so we were able to send quite a bit of work to those guys on this project also. All of the safety stickers that are on this machine, again, were made by a company that's renting space here in this business. We don't have to go far. Details on a fixture. A couple of these details, these locating datums here, were broken on the fixture when we got it. A company here, within three hours, we had new locators made, so we were able to continue on with setting the machine up. So huge advantages of having other businesses at an arm's length here in this building.
All three of these machines were came in dirty. The guys mechanically rebuilt them. What I've done personally on these is the 10-station tool changer that's up in the machine. We added a mechanical shop pin for location. Well, when adding that, you actually have to edit the software inside the computer that controls it. So what I do is I go in and edit the software, or ladder logic is really what it is, and modified that to function, including the shop pin for location of the tool changer. On these parts here, we come in, we drill this hole, and we actually open this hole up. It's a pre-casted hole. Then we come in with a different tool, reach behind the part, do a back chamfer on it, and then come in and do the front chamfer here on the front sides of it. We actually turn the fixture 90 degrees so the spindle's pointing at it back there, reach in with an end mill and machine flats on this surface. The part then comes out of that machine, goes into that machine, and we program a different application over there. That part will come out of here, go into that machine, and that chooses a different series of drills, a spot facing tool, a tapping tool, which all that programming is what I do. On this machine here, it will be the final process after it goes through these, which will finish the part, which every surface that touches will have already machined over here, but that'll be the final application where it comes in and finishes everything with just a supreme surface finish. Well,
today we've been working on setting up the Op 10 machine and qualifying it. We did some capability runs last night on it. We're CMMing parts over there at the CMM today. Currently the Op 10 machine's fed by the Op 7 machine, so right now we're powering the Op 7 machine up to run some more parts on it so we can continue on testing with the Op 10 machine. I'm also setting up the Op 40 machine. We don't have the tools in it yet, but we're dialing the fixture in, setting up the tool changer positions, things like that. If you come over here and take a look, we currently are setting up the tool changer in a test cycle so we can verify that everything's working correctly before we actually put tools in it. That way, if there is an issue, we won't harm the machine that we've put hours and hours in rebuilding. The tool changer there. We have a modification that we put on this machine as a shop pin to locate the tool changer, because prior to the machines coming into our facility, when they were in production prior to this, they were having problems with the tool changers working properly, and they were not positioning to the correct position. So we installed a tapered shop pin onto it. It'll improve the repeatability of the tool changer, and the result will allow for smoother tool changes in the machine. You can see there's a small proc switch located on the bottom of the tool changer here, and that's attached to the shop pin that'll eject in and out of the rotary disc here, which will hold the tools. And all those positions have to be set up very precisely on that. We've made some custom tools up. We've modified the tool holder and removed the bottom shank off the tool holder, so we can put this in the tool changer and clamp a standard tool holder up into the spindle. And with this in the tool changer, we have a rod that we can place through that while this is in the spindle, and we can adjust our spindle into position so the rod will slide smoothly between the two tool arms. That way it'll give you a exact position of where it's located. It'd be within, a few thousandths of an inch on location that way. This is a CMM machine that General Motors has provided us. It's actually a research and development unit that they're going with, a way of trying to conserve themselves some money on gauging. Usually they have to have a dedicated gauge for each part that they have, and it all has to be custom made, where this is going to be a way of generically testing the parts, and if the process gets canceled or moved, they can just move the part on and set it up for a different part, and it won't be a big issue, where before they would have had to scrap the entire gauge and had a new one built. Each part, when they come off the machine, is labeled in the order that they came off and what portion of the fixture that it comes off in.
Well, I think that our future really depends upon the future of the economy. You know, right now I think the economy is starting to come back. You know, it's nice because I think people are cautious right now and want to redeploy the assets that they have, and people are starting to see that, you know, they can save some money by doing refurbishing and rebuilding, okay, rather than going out and buying new.
We live in Michigan. We want Michigan to grow, and I believe it is starting to come back, and that's what this country needs, is manufacturing, industrial, to get more people working.
The more of these jobs that we get into, you know, we've only really been doing the rebuild scene for, you know, like 6 years. I think the further we get into it, the more our name will get out, and, you know, the more we will succeed.